So some days earlier this month, we established a solution for the second module, which was originally 2.2. And what we've done is taken advantage of a natural event that occurred on Wednesday. You will recall that I sent notice about class being canceled this Wednesday. You may or may not know that UVI faculty are charged with an important responsibility, that of community service. Were you aware of this? Did you know that UVI faculty, an important part of our mission with the university is to provide subject matter expertise to the islands and the territory that we serve? Were you aware of this?
No.
No, it's true. And so I had established a relationship with a very large organization, a nonprofit that touches hundreds of lives on a daily basis on each island. And they are the fifth largest employer in the territory, in the US Virgin Islands. This organization had recently upgraded their infrastructure to provide better security and reliability. And on Wednesday, I received a call that everything was down, nothing was working. Everyone was dead in the water, basically. And so I had to make a tough decision, but I thought, depending on what this is, it might actually make for an ideal case study. And that's actually the way things turned out. Remember that our solution for the second module was to configure local DNS, because if you have DNS service running locally, you have control over a critical service. And it's something that all of your social media, your social network apps, your email and messaging, the websites that you frequent on a daily basis, these are all keyed to a name. And so it's named resources that we use on a daily basis, and we don't even think about it. We go to Amazon, we go to Google, we do these things. Hackers know that the domain name system or domain name service running on a domain name server is one way to hijack and exploit the common reference that we use every day. So if you can establish, if a hacker can poison the DNS records so that when you go to a well-known website or a banking website, you can actually be redirected through your browser to their system, their server, which is fabricated and built and constructed by copying the source code of the web pages for the real website, so that the user is completely unaware, except for a few small telltale signs. The user is completely unaware that it's a fake website. It is a imitation website. It is an imposter. And at this point, when you type in your passwords and your logins, these malicious individuals are basically capturing that information. So we made it a point to ensure that you would build your own system, even if it was a virtual system, right? And at this point, what you see on the screen should look pretty familiar, right? So you have a virtual machine and it's got DNS installed. And if you look at the dashboard for this system, you would see that this looks familiar or similar to your own. So for the solution, you created your own DNS server. Is that correct?
Yes.
Okay. So here is what happened on Wednesday, without further ado. So what you see here is a system that is constructed and built much like the system I am sharing with you today. You've heard of virtual machines before. Of course, you created a virtual machine to stage your own DNS server. But it turns out that much of the world is moving into a virtual machine platform for their needs. And in this case, the organization here in our territory that serves so many people had modernized their infrastructure to include updated hardware and a virtual host so that they could run the servers that they depend upon each day on a virtual machine. In fact, this is a great example of how the network is configured in most of those cases. If you go to a host, and this is kind of an oversimplification, but this is a prototype, so it's a good demo to show this. Can you see the screen that I have here?
Yes.
So the actual physical host, has a network connection with a real Ethernet network, and it's connected to the internet. So at the headquarters for this Virgin Islands organization, good afternoon, Miss Sander, how are you? Are you there today? I'm gonna go ahead and continue. I don't know if you're in a noisy place where the microphone cannot be unmuted, but let's make sure you have audio. Aha, there you are. Can you hear?
Yes.
Okay, great. So thank you for joining us. Good afternoon, Kareem.
Good afternoon.
So we are sharing about what we discovered on Wednesday. And to give you to catch you both up to speed very quickly, on Wednesday, I had to unexpectedly cancel class to render assistance, community service, as a subject matter expert for virtual systems and technology. An organization in the Virgin Islands, the 5th largest employer in the Virgin Islands, had a system crash and they could not do anything. Everybody was dead in the water. And so this presented an extreme case. You know that part of our primary concept for cybersecurity includes confidentiality, integrity, and A for availability, right? Availability. And so I was called onto the scene to assist. And what we've discovered is a neat way to make lemonade out of lemons. So I'm going to go ahead and walk through the scenario on a prototype that works just like the real thing in this organization here on St. Croix. What you're looking at is the primary host for a whole cluster of servers. So this one physical machine actually runs 1, 2, 3, 4, 5, 6, 7, 8 different servers upon which the entire organization depends. And this one physical network connection, when you create virtual machines, it takes the actual physical network connection and it virtualizes it. In a manner of speaking, it creates a virtual switch or a virtual interface that the host can use to connect the other systems that are running on this machine to the network. So there's a critical dependency there. Now, as luck would have it, sometimes when we run our updates, right? Everyone knows that sometimes when you run updates, you have these larger updates called cumulative updates. Have you ever seen these? They come out once a month. They're very large. Yes?
Yes.
Okay. And it just so happens that Microsoft, when they discover something that's very critical, what they tend to do is they push out a change. And in simple terms, one of the realities of our world is that hardware devices execute on a very low level within the operating system internals. Put another way, the hardware abstraction layer in the Windows operating system is a very low level, very privileged area, a very sensitive area of the operating system. And for this reason, hackers love to find ways to pirate or commandeer a hardware component. And it's actually a small coup if they can capture the Ethernet interface, because the data that's flowing in and out of that system is ginormous, right? All the institutional data that people use and depend on every day is flowing in and out of that one interface. So basically, if they can find a way to sniff that network connection, to capture the contents that are being transmitted and received, or if they can impersonate a connection again, they'll do it. So oftentimes Microsoft will come out with a digitally signed hardware driver. What this means is that when updates are running, when you're running Windows updates, for a server that houses many systems, the same principle holds true. If there are critical updates, usually it prompts you. But in extreme cases where there are security challenges, Microsoft labels those as critical, and it'll often push those to load immediately because they don't want people vulnerable. They don't want malicious actors getting on your servers, in your data centers, on your systems, getting into your Kool-Aid and your data. So what they want to do is make sure that if there's an open door, they close it as soon as possible. What will happen is that if that driver for the network card pushes and loads and it disrupts this connection, then what will happen is that the connection reverts to a default or dynamic assignment. Now, as you look at it, we've explained that servers, large systems that have resources many people depend on, it's best to have a static address or a manually assigned Ethernet address. Instead of obtaining an IP address automatically, what we want to do is put a fixed or unchanging or static network address on this interface, right? And that's what's happened here. As we built out the hardware of this system, this prototype, as soon as we established the role for it to host virtual machines, it built a replica of the original interface in the virtual realm. So there's a virtual network interface here. And this network interface has assumed the same network address as the original. So you build the virtual servers and you're none the wiser because your original host machine continues to operate on a fixed address and everything's good. But if that driver update with the security patches each month load and everything isn't 100% bug-free, what can happen is that it will reset the drivers for this network interface, and the default setting of obtain an IP address automatically occurs. Now that's when all hell breaks loose, because there's a whole network of devices that expect to find this system and its servers right where it left them on a static, unchanging IP address. That's how DNS works. As soon as we default to this dynamic mode, it's going to pick up an automatic address, a different address that is dynamically assigned by a service called DHCP. Has anyone here heard of DHCP before? Does anyone know what DHCP is from our network course? It's the service that your wireless router uses to automatically assign network addresses, right? It's also the service that is used when you connect to the Wi-Fi at Buck's Wi-Fi, right? The Wi-Fi at our campus at UVI. When you connect to the Wi-Fi, you're automatically assigned a network address. And if you disconnect and come back the next week, it's going to be a different address. There's a pool of addresses. They're dynamically assigned. In most cases, when you connect to most networks, the network addresses are dynamically assigned based on the pool of available network addresses, and those change from time to time. But if you have a server that's being used by everyone for resources, you don't want that network address changing. I mean, how would you get to Google or Amazon or Facebook or Snapchat or any of the things that you like, WhatsApp, if the addresses were always changing all the time and the domain name service kept pointing to the old outdated address, what would happen? It wouldn't work, right? So what happened the day before on Tuesday is that an update posted, a critical update posted, and it changed the setting, and the connection and interface between the virtual servers and the actual physical server were scrambled. And when this goes into an automatic dynamic mode, if it gets a different address, nothing knows how to find it, including the virtual interface that all of these servers uses to serve up resources for everybody else. So we have a dependency, and we also have a single point of failure. The goal today in class is to take our lemons from Wednesday and find a way to enhance the system that you set up for DNS. Okay, so now what we'd like to do before we switch gears and talk about the assignment, let me just ask, does anyone have any questions about this prototype that I just walked through to share with you about what happened on Wednesday? Does everybody understand the basics about what happened? There was an update, the interface changed, it wasn't on the same address anymore, nothing on the network could find it, so you couldn't log in, you couldn't access your home folder, you couldn't access the internet, anything. You couldn't do anything. Does everybody get that much?
Yes.
Okay. So you went to the trouble of installing a DNS system for your home environment, your home network. That was our solution. And what I've done is tweaked the number for this solution. Instead of being 2.2, it's 2.3. And I've posted this assignment. It's a 2-point assignment. And I'm going to show you how you can set up service redundancy with a very simple method to prevent the same kind of thing from happening. So what am I saying? For networks that are important, for organizations in our territory that serve many, many people, the last thing we want is for a simple outage to keep them from providing services to people, right? Our whole point of Module 2 is to find ways to enhance the security for hardware, software, and services. And that includes network services. What we're going to do is take this concept of how DHCP works, and we are going to use a feature called DHCP reservation to ensure that our server will never lose its network assignment, even if it switches into automatic mode, even if it switches into dynamic mode. So in order to do this assignment, you really need to have the solution in place where your virtual machine is running DNS and it's on a fixed IP address. If it isn't on a fixed IP address, we're going to show you how to change that. So does anyone need us? I think in a previous session, we showed you how to change the address on the server. Does everybody remember that one?
Mhm.
We were in this environment on our virtual machine on the server that you built for DNS and the solution. Is everybody with me so far?
Yes.
Here it said for the IP address, it might say assigned by DHCP. If you click on it, you can go into your virtual server that runs DNS and you can assign a static address. And that's what part of the process was for the solution. Now, let's pretend that this network card experiences the same kind of update failure or fiasco that the main virtual host at our Virgin Islands organization encountered, right? They experienced this. So we're gonna go ahead and see how this works after we set it up. We're gonna set up a fail-safe or a service redundancy so that if we have an update of this physical interface and it automatically reverts to dynamic network assignment, it's gonna still get the same exact address, okay?